Hi, welcome back to Dissolved Chemistry. Let us continue our discussion on mission 70. So in the previous video, we have started our discussion on numerical problems on the solutions, as already it is being mentioned. So that there will be two numerical problems on this solution and one numerical problem on what topic it appears, that we have discussed in the previous video. So those topics are more the expression of the concentration and then Raoult's law and Henry's law. These are the three important topics. On that one numerical problem may appear, and another numerical problem will be mandatorily, it will come from the colligative properties. 4 colligative properties are there and 4 formulas are there, and if you remember those 4 formulas, then you can easily solve one problem and you will be getting 3 marks very easily, and you can do that in a fraction of minutes, right? So let us start with the formulas, what formulas you come across in these numericals, right? And followed by that, we will go with the numerical problems, right? The first one is a relative lowering of the vapor pressure. So the formula is molar mass of the solute is equal to, okay, so weight of the solute in the given solution W2 divided by weight of the solvent here into molar mass of the solvent, okay. So then into P naught, where P naught is vapor pressure of the pure solvent. P naught minus PS is the difference in vapor pressure of the pure solvent and solution, okay. So this is the formula what we are supposed to use to calculate molar mass of the solute by using relative lowering of the vapor pressure. This you should remember, first formula. And the second one is, that is depression, elevation in boiling point. We will take elevation in boiling point. How these formulas will come, all that we have discussed in one video we did on theory part. So there, please go through that prior to watching these numerical problems, right? So here how we will write elevation in boiling point. First we will write, so delta TB, difference in temperature, boiling temperature, is equal to KB into molality. So therefore the formula turns out to be M2, we will take it as M2, and W2 divided by into KB, okay. So here it is divided by solvent, weight of the solvent, into KB, into here it is delta TB. So this is the second formula that what we are going to use, okay. So if the weight of the solvent is given in terms of grams while solving the problem, so therefore if it is given in terms of gram, either you multiply in the numerator with 1000, or you initially you convert this in terms of kilograms and then you substitute, okay. So that you should remember in solving the problem, I will tell you. Then the third one is depression in freezing point. Depression in freezing point. How to calculate molar mass by using depression in freezing point? So that we will write M2 is equal to Kf into W2 divided by delta TF into W1. Same formula is there. Only thing is, instead of KB, here we have taken KF. Instead of delta TB, here we have taken delta TF, okay. You make sure of this. So this is another third formula on which we are going to get the numerical problem. And fourth formula is osmotic pressure. Fourth colligative property, osmotic pressure, and how we calculate molar mass by using osmotic pressure is M is equal to RT W divided by volume of the solution in terms of liters. Again, once again you should remember this, into pi osmotic pressure. So this is the fourth formula that we are going to use to solve the numerical problems. And all, if you remember only these 4 formulas, so you can solve one problem which carries 3 marks, right? So as our mission is 70, even single mark is also very important. So therefore you should not neglect any single point, right? So let us start with the problems. So on dissolving 2.34 gram of solute in 40 grams of benzene, the boiling point of solution was higher than that of benzene by 0.18 Kelvin. Okay, directly delta TB is given, difference is given. Okay, and Kb value for, Kb means ebullioscopic constant value for benzene is 2.53 Kelvin kg per mole. Calculate the molecular weight of the solute, right? So first thing is, as in the previous video we have mentioned, you have to write the given quantities. So the given quantities are what? So first one is weight of the solute, W2 is equal to 2.34, okay, grams, and W1 weight of the solvent, that is 39 grams, okay, grams. Right, then next is delta TB is equal to lowering of difference in boiling temperature 0.81 Kelvin, and then Kb is equal to 2.53 Kelvin kg per mole. Okay, let us write the formula. So molar mass of the solute is equal to M2 is equal to, or just you can call it as, okay, M2 we will take, right? So W2 into, first we will write Kb into W2 into 1000 you can take, or else what you have to do, you have to convert this in terms of grams, is there no? So here only you can convert it 0.039 kg solvent, then no need to multiply with the 1000, directly you can substitute that, right? So then your delta, delta TB into W1. So therefore directly we will substitute the values. M2 is equal to Kb is how much? 2.53 into W2 is 2.34. No need to multiply 1000 because already I have converted that into kilograms. So therefore W1 is 0.039 kg into, so your delta TF is 0.81. Okay, if you solve this, 182.7 grams per mole. Unit you should remember. Okay, you should not forget writing the units, because without unit answer is having no meaning. Okay, we lose the marks. Fine, let us move on to the next problem, right? The vapor pressure of pure benzene at certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram when added to 39 gram of benzene. Okay, molar mass of benzene is given as 78, and then vapor pressure of the solution was found to be 0.845 bar. Then what is the molar mass of the solute? Okay, so you should remember how to solve this problem. See here, a benzene is taken, that is 39 grams, right? So to that, what its vapor pressure was, initial vapor pressure, okay, so that was found to be 850 bar, 0.850 bar, okay, initial vapor pressure, and then a solute is being added to that. How much solute we have added? So that is around 0.5 gram is being added. Once if it is added, then the vapor pressure has been decreased to what? 0.845. Okay, so this difference, by getting this difference in the vapor pressure and amount of the substance and amount of the solvent, you are expected to calculate what? Molar mass of the solute. Okay, so that we can know. This is what is problem on the relative lowering of the vapor pressure. So let us write the formula. So M2 is equal to W2, weight of the solute divided by weight of the solvent, into, here what you write, W2 into molar mass of the solvent into P0, vapor pressure of the pure solvent. Here you have to write P0 minus PS, right? So this is what is the formula. Okay, so therefore M2 is equal to write the given quantities. You have not written, so please write the given quantities. Just I have illustrated here. So W2 is equal to 0.5 gram. Okay, W1 is equal to 39 gram, and pure solvent vapor pressure is 0.850 bar, and vapor pressure of the solution is 0.845 bar. Okay, so these are all the given quantities, and molar mass of the solvent is also given 78 grams. Okay, it is given in the bracket. So all that we will substitute. So W2 is 0.5 into molar mass is 78 into pure solvent is 850 bar divided by weight of the solvent is 39 gram into P naught minus PS. So 0.850 minus 0.845. So that turns out to be 170 grams per mole. Okay, so this is how you are supposed to calculate and the relative lowering of the vapor pressure for the problem given on the relative lowering of the vapor pressure. Fine. So let us move on to the next problem. A solution containing 18 gram of non-volatile non-electrolyte solute is dissolved in 200 gram of water, freezes at 272.07 Kelvin. Calculate the molecular weight of the solute given the cryoscopic constant 1.86 Kelvin kg per mole and freezing point of water is given as 273 Kelvin, right? Let us look into this solution. Okay, so your pure water, if you take 200 gram water is taken and it used to freeze at 273 Kelvin, already we know that one. And once if you add the solute, how much you have added? Non-electrolyte and non-volatile solute when you add. So then what happens? Your freezing point goes to 272.07 Kelvin. Okay, this must decrease in the freezing point we are going to observe upon addition of the solute. So therefore let us write the given quantities. The weight of the solute is how much? So we will write like this. W2 is equal to 18 gram. Weight of the solvent is 200 gram. If you want to express that in terms of kilograms, so therefore what you have to do? 0.200 kg. Okay, so then your delta TF decrease in freezing point. So 273 minus 272. I will write like this: 273 minus 272.07. So that turns out to be 0.93 Kelvin. Then last one is KF. Already it is being given 1.86. Okay, so 1.86 Kelvin kg per mole. So that what it is being given. So directly we will write the formula. Molecular weight of the solute is equal to KF into W2. Okay, already we have converted weight in terms of kilograms, so therefore no need to multiply with the 1000, right? Let us write. So weight of the solvent into delta TF. So let us substitute the values, right? So first one is KF 1.86 into W2 is 18 gram divided by W1 is 200 gram into, so that is 0.93 Kelvin. So therefore if you solve this problem, so then you will be getting the molecular weight 180 grams per mole. Okay, one thing you should remember in the textbook and all that, if it is taken in terms of grams, okay, weight of the solvent, so then they used to usually multiply with the 1000. Already if you convert here only, you can avoid the confusion. So therefore grams, if it is given in kilograms, no need to convert. If it is given in terms of grams, you have to convert it into kilograms. Okay, so both in elevation in boiling point, depression in freezing point, and even osmotic pressure, they will give the volume in terms of milliliter. There you are supposed to convert into liters, right? So in these three colligative properties, you should remember this conversion. And if you fail to convert that here only, then your problem, the answer what you get, that will not be appropriate. Fine. So let us move on to the next. Okay, the next is the boiling point of benzene is 353.23 Kelvin when 1.80 gram of non-volatile non-ionizing solute was dissolved in 90 gram of benzene. The boiling point was raised to 354.11 Kelvin. Calculate the molar mass of the solute. So given that Kb is equal to 2.53 Kelvin kg per mole. Okay. So again it is the problem on what? Elevation on boiling point. So therefore elevation in boiling point. So what you have to do, see here, delta TB is equal to, okay, boiling point of the pure solvent minus boiling point of the solution. So therefore the values given is 354.11 minus 353.23. Okay, so that comes around, so delta TB is equal to delta TB, then followed by that what it is being given, W2 is equal to 1.80 grams. Okay, then next is after this W2, so weight of the solvent W1 is equal to 90 grams. Okay, so then next is weight of the solvent, then oscilloscopic constant Kb is equal to 2.5453, okay, Kelvin kg per mole. So like that it is given. So therefore write the formula. So molar mass is equal to Kb into W2 divided by W1 into what? Delta TB, delta TB. So therefore M1 molar mass of the solute is equal to Kb is nothing but 2.53, okay, into weight of the solute is 1.80 divided by, next is 90, okay, into how much it is, 0.88 Kelvin. Okay, so if you simplify this, grams per mole, okay, molar mass is equal to 57.5. So here the solvent it is given 90 grams, so that we have expressed in terms of what? 0.090 what? Kilograms. So therefore directly we can substitute and get the value. Okay, let us move on to the next problem. So when 200 cubic centimeter of an aqueous solution of protein contains 1.26 gram of protein, then osmotic pressure of such solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. Calculate the molecular weight of the protein. Okay, so first thing is we will write the given quantities. So pi is given 2.54 into 10 to the power minus 3 bar. Okay, then temperature 300 Kelvin it is given. Then volume of the solution, that is 200 cubic centimeter means ml. So that if you want to express in terms of a liter, how much it used to be? 0.200 liter. Okay, so then next is pressure, volume, temperature. So then weight of the solute, how much it is? Weight of protein is 1.26 grams is being added to that. Then molecular weight of that is being asked, right? So therefore molecular weight is equal to W1 into RT divided by pi into volume we will take. Okay, here it is volume, right? W2 is 1.26 into R is 0.0823 into temperature to 300 Kelvin divided by pi is how much? Pi value is 2.54 into 10 to the power minus 3 and volume of the solution 0.200 liter. Okay, So now when you solve this, 62,000. So you might be wondering by looking into this value, because we get such values because it is a protein. Proteins are a high molecular weight compounds. Already we know that one. So because of that reason, that molecular mass we are going to get like this. Fine. So let us move on to the next problem. This is on osmotic pressure, right? So I believe that we have solved one problem on each colligative property. We will repeat, means little with differences. So we'll see the problems, right? Let us move on to next. Okay, 5.8 gram of non-volatile solute was dissolved in 100 gram of carbon disulfide. The vapor pressure of the solution found to be 190 mmHg. Calculate molecular weight of the given solute. The vapor pressure of the pure carbon disulfide is 195 mmHg. The molar mass of carbon disulfide was found to be 76 gram per mole. Okay, so once again it is on the lowering of the vapor pressure, right? So I will put it into the formula just to solve the problem. Okay, given quantities, let us write. Given quantities, the first one is P naught, vapor pressure of the pure solvent is how much? 195 mmHg. Okay, PS, vapor pressure of the solution is 190 mmHg. Weight of the solute W2 is equal to how much it is? 5.8 gram. And weight of the solvent, okay, so that is equal to 100 gram. Molar mass M1 is equal to 76 gram per mole. Okay, so we know that the formula already. We have done problem on this. So therefore M2 is equal to, so what we will be having the formula, W2 into M1 into P naught divided by W1 into P naught minus PS. Okay, so therefore substitute the values and try to get the answer for this. Alright, W2 is 5.8 into M1 is 76 into P naught is 195 mmHg divided by, so W1 is 100 gram, okay, into P naught. Here you are not expected to, because we are calculating mole fraction. So therefore no need to convert 100 gram into kilograms. Okay, it is not required in vapor pressure. You should make sure of this. So how much it is? 195 minus 190. So that comes around 5.8 into 76 into 195 divided by 500. So therefore that corresponds to M2 is equal to 171.9 gram per mole. Okay, so this is how we are going to solve the problem on vapor pressure. Okay, second problem we have done on this. Next, let us move on to the next problem. Okay, in this new blueprint already they have given the problems as Hart's high order thinking. So slightly modified problem I have taken, so which is on depression on freezing point, right? So what they have done is two elements A and B form compounds having formula AB2 and AB4. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of same 1 gram when you take AB4, it lowers it by 1.3 Kelvin. Okay, so the molar depression constant for benzene is 5.1 kg per mole, Kelvin kg per mole. So calculate atomic mass of A and B. So first what you have to do is you have to calculate the molar mass of any one of the compound, that is AB2 we will do, and followed by that we will do the AB4 molecular mass, then followed by that we can separate and we can get the answer, right? So we'll do that one. So to get the atomic weights of A and B, let us calculate molar mass of AB2 first. Okay, so molar mass. So what are the given quantities? Weight of the compound is given 1 gram, right? Weight of the solvent given is 20 gram. Okay, molar mass of the solvent, it is benzene, so therefore already we have seen in the last problem 78 gram per mole. Okay, anyhow we won't need its molar mass, so we will not take that one, W1. Okay, then next what is given? So how much lowering of the freezing point is there? 2.3. Delta TF is equal to 2.3 Kelvin, and Kf already it is given 5.1 Kelvin kg per mole. Okay, so what you will be getting? So you substitute the value. The molar mass of AB2 is equal to how much it is? So it comes out to be, formula is W2 into Kf into 1000. 1000 why we are doing? So already solvent given is what? So 20 gram it is, fine. So if you want to express that in terms of kg, or you can take, instead of taking 1000, you can take 0.02 12302 kg, like that we can take W2 divided by W1 into delta TF. So therefore that is W2 is 1 gram into Kf is 5.1. So divided by delta TF is 2.3 into your W1 is 0.021. So therefore you will get the answer as 5.1 divided by 0.0483. Okay, so you will be getting molar mass as 105.59 grams per mole. It is a molar mass of what? AB2. Molar mass of AB2. So then if you get the molar mass of AB4, so then it will be very easy for us. Difference if you take, then you will get a molar atomic mass of B, and from that we can get the atomic mass of. We will write one side, AB2 is equal to 105.59 gram per mole. Okay, so this we will keep it aside. So then let us calculate for AB4, right? So AB4, once again we are adding the same thing, only temperature change will be for what? It is 1.3 Kelvin, right? Rest things are same. 20 gram we have taken, added is again 1 gram. So therefore for AB4 what you have to do is you change the value here. It is 1.3, right? So when it is 1.3, so then what you will be getting? 0.027. So you will be getting molar mass as 188.88 as molar mass of AB4. Okay, so now the atomic weight of, how we can calculate atomic weight of B is equal to, so molar mass of AB4 minus molar mass of AB2, the difference is what? By 2B. So therefore if you divide that by 2, so then you will be getting atomic weight of B. Once you know the atomic weight of B, then if you substitute, then you will be getting atomic weight of A. So let us do that one. So 188.88 minus 105.59 divided by 2. So it turns out to be atomic weight of B is 41.64. Okay, so atomic weight of B once you know. So let us, atomic weight of A is equal to molecular weight of AB2 minus 2 into atomic weight of B. So then you will be getting atomic weight of A. So therefore A is equal to 105.59 minus 2 into 41.64. So that turns out to be how much? 64 means 8, 12, 1, 3, 8, 80, 105.59 minus 83. So that comes out to be 22.31. Okay, so this is the atomic mass, okay, gram per mole of A. So that is how we write gram per mole of B. So that is how, so you will be getting applied questions may get. So therefore I have taken one problem or like applied type, right, where we are expected to calculate the atomic mass. Fine. So I hope you have understood these problems, right? And in the upcoming video we will discuss MCQs, how to solve those MCQs. So, and please subscribe our channel, and please be with us till your board exam completes. Thank you for watching.